This is the presentation for the Learning Factory Showcase for the Lockheed Martin 2 Machine Learning / AI Search and Rescue Team. A search and rescue mission involves locating lost or injured people in the context of a natural disaster. And for our situation, we are locating buildings and seeing if a natural disaster actually occurred within that image. So the custom requirements include the user interface shall display each individual image and the entire geospatial world. The AI/ML process should search each image and determine if the effects of a natural disaster are evident. The UI will display the accuracy of such results. The GUI was written in the Python language using primarily the Kinter package. We designed a UI that allows the user to choose which disaster to test a game board of 9 images to see what the AI/ML predicts. Once you select a disaster, it will call the function on the back end to start, which will be explained in more detail by Collin.
For the first part of the algorithm, we use dbScan or density-based spatial clustering of applications with noise based on the red, green, and blue pixel densities from each image. dbScan clusters the pixel densities based on distance. If a pixel density is not considered to be within a cluster, this point is labeled as noise. A support vector classifier, or SVC, is applied over the clusters to create boundary lines for the feature classification. The feature classification output is used as an input for the residual neural network for classification of the scene within the image, which is what Alex will talk about now.
So a residual neural network, or ResNet for short, is used for the classification of scene-based images. Once the neural network trains on the training set of images, this network is tested over the validation set of images to optimize loss and update parameters of the network. After the updates, the network is fitted over the testing image set for the final classifications of the scene-based images and determine if the image is the specified natural disaster or not. The output of the classifications is sent back to the GUI for display.
According to our results, we ended up getting the correct disaster percentage to be 100%, which means each disaster that was a disaster was correctly predicted on. However, for this run, the normal photos were incorrectly labeled as disasters. Thank you for spending the time listening to our showcase. We invite you to read our report for an in-depth analysis regarding the process in detecting the natural disasters within images.